Systems in 1999 as NewSpace to be a catalyst in the development of affordable, high-performance satellite components in spacecraft. Andrews then founded Spaceflight Services, the space logistics company, in 2010 to provide cost-effective commercial rideshare launch services that open up access to space for more solutions and organizations. In 2014, Spaceflight expanded its services to include Spaceflight Networks, a business dedicated to cost-effective spacecraft communications and operations for small satellite providers. Under Andrews' direction, all of these companies were combined and rebranded under the Spaceflight name in 2015 to form Spaceflight Industries. Now, Andrews and Spaceflight are out in the landscape of Earth imaging with Black Sky Global, a given point on the planet with a time resolution of only hours. Please join me in welcoming Jason Andrews, CEO of Black Sky Global.
Okay, can everyone hear me? Well, first of all, I want to thank NewSpace for allowing me to be here. It's actually an anniversary this week. 20 years ago this week, I joined the NewSpace industry. Actually, I joined the space industry. I took my first job out of school at a company called Kistler Aerospace Corporation, which was one of the NewSpace in the mid-90s that was there to launch all the satellites for Iridium, Teledesic, and Globalstar. And so we lived through the first, or me personally lived through the first NewSpace revolution in that we developed a company, we went out and raised $400 million. It was there, a lot of capital was flowing into the market, billions of dollars flowing into companies like Teledesic, Iridium, and Globalstar. And that party went on for about three and a half years. Unfortunately, the party came to an end in 1998 when all those companies went bankrupt. And Kistler ultimately struggled and had to reset, and I ended up leaving. So what I want to do today, during that time I came to my first NewSpace conference, and if you remember, it was probably a fraction of this size, probably like 25 to 50 people. And Rick Tumlinson will get up and he'd yell into the microphone, "Welcome to the revolution." And so it was exciting. It was an exciting revolution at the time to be part of that industry. But unfortunately, it kind of went into a dark period because once the street and all the financial markets lost billions of dollars on those companies, there has not been major investments really for 2 decades until now. And I feel like we're starting to live through a revolution, and hopefully this one has more legs and will last longer. And so what I want to do this afternoon, I recognize that Starbucks closed at 2, now it's sometime after 3, and so we're trying to stay awake, so hopefully I can do that. But what I want to talk about, I'll tell you a little bit about my companies, talk about my journey through NewSpace, and talk about where we are today, because it's been a bit of a wild ride through as Hannah described in the introduction, and more importantly, talk about where we're going and the excitement about what we're doing, not only in spaceflight, but in the Black Sky. And it's not just us, there's a lot of people who are a part of this excitement, and I will get to that in a second. But going back to the beginning, again, I cut my teeth at Kistler Aerospace Corporation. I left and started my first space at the time. And what we were, having just been part of a company that went out and raised $400 million in private equity, and unfortunately spent a lot more than that, I wanted to focus on revenues. And so we went out to the U.S. government, working for NASA, worked for the Department of Defense, worked on commercial programs. Had many dubious honors. We were a NASA COTS finalist, which is the Cargo Logistics and International Space Station, the commercial contract. We were a finalist twice. We were the only company to do that, not win at a time, which just meant we spent a hell of a lot of money and didn't get anywhere. We had other great foray space into space transportation. But ultimately, I feel your pain sitting in the audience. If you're an aerospace entrepreneur, I've lived through it. Going up against the military-industrial complex is very difficult, and I've learned those lessons. And so in 2008, after being at it for 8 or 9 years, I pivoted the company and focused on this emerging technology called CubeSats. So this is 2007, 2008. CubeSats are ubiquitous today, but a decade ago, it was very much university lab stuff. No one had really come up with a commercialization case. The government wasn't thinking about CubeSats. In fact, the government looked down and looked at them as just toys that should be discarded. They call them space debris. So at the time, there was an economic trend where small satellites in the U.S. government today, they weigh 400 or 500 kilograms. They cost $150, $200 million to put on orbit. At the same time, these CubeSats were out there that weighed 5 kilograms and cost a couple $100,000 to put on orbit. We were system engineers, we'd done a lot of programs, and we looked at it and said, well, there's a big gap between those two. There's a lot of room for innovation. One's is hundreds of millions of dollars, one's hundreds of thousands of dollars, one's hundreds of kilograms, one's single digit. And we said, the answer is, what everyone really wants to do with these satellites is they want to do the same mission of the big satellite, but they want to do it smaller, faster, cheaper. And the answer is probably around 50 kilograms. So we pivoted our company, we focused on small satellites. I ended up buying an avionics company because if you actually looked at the market, there were no components to enable high-performance small satellites. And so what we did is we started focusing on developing the basic infrastructure to enable these small satellites, believing that the future revolution was transitioning from big monolithic spacecraft to constellations of small spacecraft. At the same time, we got a contract with the U.S. Army. This is down in Huntsville, Alabama. They just fought the wars in Afghanistan and Iraq, and all the troops were dying in the fields because we did not have the overhead satellite imagery in order to provide them that situational awareness. They're running into towns with maps that were decades old, and they were getting in firefights, and they were getting stuck, and they had no way to get out, so they didn't know where they were. So as we all know the story, UAVs came around, and they quickly were mobilized to go off and fight the wars. But the UAVs were great locally. They were cheap to build, but they were very expensive to operate. They tended to get shot down or crash. They required people to refuel them. They required people to operate them. So they already had a single vision, and their vision was, I want to take these UAVs, they only cost a couple $1 million, and I want to put them up in space. And that way, they're cheap to build, but once I put them up there, they operate for years, and they're a resource. And that way if I can build them cheap enough, I can go off and get this virtual persistence deployed constellation that allows me to look at the battlefield in near real time. And that's a really hard problem. If you really think about that, the state was they want 1 meter imagery, and a 1 meter imagery satellite, whether you bought it from Surrey or Sierra Nevada or another company out there, those satellites cost hundreds of millions of dollars. And so the Army wanted us to do 2 orders of magnitude reduction. So, hey, UAVs cost that, why can't you take UAVs and put them in space? So we set about solving that problem, and the second problem we had to go off and solve was how do I go off and launch 60, 70, 80 satellites a year or more to enable this constellation? And so we went off and, while my company was focused on the satellite problem, I went off to solve the launch problem. And we went around and we talked to SpaceX, we talked to ULA, we talked to Orbital Sciences, we talked to business. And what they said is, we get these requests all the time for second-grade payloads. And at the time, what we wanted to do was launch them all the commercial cargo logistics missions to the ISS. They flew out regularly, they're in mid-latitudes. And they go, we really don't know what to do with this opportunity. It's not cost effective for us, but you might want to think about doing that as a business. And so being an entrepreneur, I said, hey, that's a great idea. Because my new business plan to be a small satellite contractor was not going to be, live very long if I couldn't figure out how to get access to space. So I started my second company in 2010 called Spaceflight Services. And lo and behold, it grew very fast. And what it really was a market opportunity. We were in the right place at the right time. There was, I'd say an imbalance in the force to play off Star Wars, but at the same time, really large launch vehicles and we have small satellites, and they're out of balance. And so as a result, what we did is we came in and we bought the excess capacity in all the rockets out there, and then we packaged up a bunch of small satellites, certified it for flight, and handed off to launch service providers, and that became business. And it's grown very, very fast. It's now expanding into different markets. And then finally, we realized in the company's life cycle, hey, we build components, we build satellites, we launch satellites. Really, that's only the first part of the economic problem. The second part of the economic problem is these satellites are only good if you get the data back. And there's really not a good business out there or a system out there. There's not a cell phone network for space. There's not a 4G network for space. Where you walk outside, you connects automatically, and automatically download information. So we created Spaceflight Networks in 2014. So just talk a little bit more about those companies. That problem, CubeSat, big satellite, what's the answer? We looked at the problem and we came up with a product line that we call Sentry, and there's multiple different sizes. And what you see on the far left there is a CubeSat form factor, which is 10 centimeter cross section. Then one next to it's an nanosat with a 20 centimeter cross section. The one next to that, the big one, which is more than life size in that picture, is a 40 centimeter cross section. And we really that was the sweet spot, that was the answer. That's where you get the best optimization of size, weight, power, and cost. Because you can still use CubeSat form factor components, you can still use commercial grade parts, but at the same time you've drastically reduced the size of that satellite. We can build it cheaply, and we offer that today. The one next to it is the imaging satellite. If you remember that story about the Army, our contract turned into a program which is now called Kestrel. We're building one of those UAVs in space for the Army called Kestrel 2. And it has 1 meter capability operating 450 kilometers. It's a 50 kilogram satellite, and it is the bleeding edge of performance, size, and cost that's out there today. But along the way, it took us 5 years, and that's because we had to develop a whole suite of products and components to make it happen. We had to develop our own avionics because nothing existed at the time. And realize today, if you go to SmallSat, you see a lot of this equipment, but this was in 2008 and 2009. This was 5 years ago. We had to develop power systems. We had to develop star trackers. We had to do propulsion systems. This ecosystem of components, currently a growing ecosystem of components that are enabling the operation of small satellites. At the same time, we then went out and did our launch business. So what we do is we find your launch. We're working with every launch service provider on the planet, with the exception of the Chinese, and that's because of regulatory reasons more than our desire. Basically, if you have a rocket going to space, more than often than not, you have excess capacity, and we go off and resell that excess capacity. But what we do is we get your payloads, we integrate them, we certify it for flight, we get it on that launch vehicle, and we get it flown. And to date, we've launched 76 satellites. First launch was in April of 2013. We started off satellite on a NEPR launch vehicle. We actually Planet Labs' first satellite. We also launched on Atari's flight. We launched 3 sats for NASA Ames, the phone sats, as well as a Planet Labs satellite. We've launched work to deploy a large number of their satellites. And at the same time, there's large demand, as we talked about. We have well over 100 satellites that we're looking to fly. And as demand has increased, we've had to innovate and create infrastructure to support spacecraft. So we have a system that we call Sherpa, which uses a Moog CSA ring, and it's an Espadronde ring, and we've built ports that go around that. So the ring has 5 ports, each port can carry 300 kilograms, and we've developed infrastructure to support spacecraft that fit on those ports. So this flight's going up on a SpaceX Falcon 9 in the first quarter of 2016, fingers crossed. With 7 payloads on board. It's actually slightly more than that because one of the satellites we deployed in deploys a bunch of other. That will be a record. And we're involved in continuously breaking records as far as the total number of satellites deployed in space. We were part of the launch in 2013, and I set the current record, which is currently sitting in the mid-30s. We have significant demand, enough demand that we're in the process of buying our own dedicated launch vehicles. We're talking Falcon 9 class vehicles. There are dozens of microsats out there, and there are hundreds of CubeSats out there that are looking to go to space on a regular basis. And I'll talk about why in a second. And finally, we're also working to stimulate the small launch vehicle market. I know that's been discussed here on this panel. We have agreements with multiple small dedicated launch vehicles to use them to help grow our business and support our customers. And the key part of what there's a funny thing in the aerospace industry. We like to hold all our data really close. No one publishes pricing, no one publishes. We think about the launch business, it's really a space transportation business. You just want to get there as quickly and reliably as possible. We all go online, we go to the airlines, we pick out our seat, we pick our class of service. But we do the same thing in the space business. So what we did is we established standards with the size of spacecraft, the mass of spacecraft, and we published pricing. And this pricing hasn't really changed since we first put it online in 2010. And you can see pricing to low Earth orbit. We also have pricing to go out to GTO, and we even have pricing that goes beyond that. Our biggest contractor is a customer that actually wants to go all the way out to the moon, but we've talked to people about going much farther than the moon, and we have significant levels of pricing. And then finally, you got to publish a schedule. So all this is online at our website, spaceflightindustries.com. I'm not going to bother going through it here, but I think this is an important tenet about where space is going. When we talk about NewSpace, we're really talking about, on the previous panel, they talked about the operationalization of space. That's a hard word to say at 3:30 in the afternoon. And that's really what I think we're doing, and other companies like NanoRacks and others are out there doing. We're providing much broader access to space. We're to space And that's a really exciting thing, because what it's going to do is open up a lot of market opportunities. And then finally, we talk about our customers who have to go to space. They got to get their data back. And so we've had a lot of announcements. We announced our Spaceflight Networks initiative a year ago. We had another announcement that came out this week about partnerships. And really, this is the cell phone network for space. There was no company out there that, when you walk out of the room, your cell phone just works. It talks to the cell towers and the ground networks. There's no for space. That's what we've done, is we've standardized the ground radio, the spacecraft radio. We've leased a bunch of dishes, and we offer data plans. We talked to the legacy vendors, and we started thinking about constellations of dozens of spacecraft or hundreds of spacecraft. Traditionally in space, people lease a single dish for a single satellite, $500 every time it flew over. But we went to them and said, well, wait a minute, customers that have 50 satellites, the dedicated access to the dish, and they kind of look at you sideways. It's kind of like walking into a bar and pointing to that bottle of whiskey on the shelf and saying, I want that bottle of whiskey. And they look at you and go, well, we only sell it by the shot. And you're like, but and that's how the conversation ends, because it just hurts their head, because that's not how their business is operating. So what we've done with Spaceflight Network is enable that business where you can buy dedicated access to the dishes, or you can buy the drink. But ultimately, what we're trying to do is bring down the cost of operating these constellations so people can make money in space. So over the last 16 years, it's been a journey, it's been an odyssey to create this business, Spaceflight, that basically works from cradle to grave. And we're super excited because we're helping enable the small sat revolution. And that's what I want to spend the second conversation talking about is, okay, so why is everyone launching these small satellites? What is the killer app? We sit here in Silicon Valley. There's been huge announcements in the last. Planet Labs raised $115 million. Spire raises $40 million. This is real money. Why are the VCs down here throwing all this money into the small satellite community? And that's because Moore's Law has finally come to the aerospace industry. It's to the point where, if for those who are older in the room, if you remember Augustine's Law, he projected that the cost of a single fighter would take up the entire defense budget if you kept extrapolating the rate that things were increasing in price. The same is true on our government space programs. I mean, those satellites cost billions of dollars each. It costs $1 billion to build a satellite. You're going to spend $1 billion to make sure it gets, and it just feeds on each other to the point it becomes unaffordable. And so now comes Moore's Law. My personal opinion is the reason Teledesic and Iridium and Globalstar failed back 20 years ago was because Moore's Law killed them. Back then, the internet was in its infancy. There was a race to build out cell phone networks, to build out the internet, and it wasn't clear who was going to win. Was it space-based infrastructure? They faster than terrestrial networks, or it was going to be the terrestrial networks. And ultimately what happened was the guys that were focused on the space solution used a traditional aerospace approach. I'd take 3 years to develop my technology. It's going to take 3 years to launch my constellation. And to make that billions of dollars I borrowed to make this work, it's got to operate in space for 6 or 7 years. Well, if you add that up, 9, 10 years in total, that's 4 or 5 generations of Moore's Law. So if you were going after cell phones 1.0, and by the time you got in orbit, you're already at cell phone 4.0, and by the time I'm ending, I'm cell phone 9.0, I'm not very relevant. And so as a result, Teledesic went bankrupt, so did Iridium and Globalstar. The only reason they came back is they found niche markets, like in the maritime industry, where there was no terrestrial equivalent. But the reality is, Moore's Law marched on, and that's why everything was built out terrestrially. So personally, I'm actually a skeptic of the current internet revolution and OneWeb, because if you don't solve the problem I just described, the same thing's going to happen to this generation of spacecraft. So take that as food for thought if you guys out there planning your. It's important about spacecraft, and Planet Labs is a great analogy here. With everything in the consumer electronics market, people are pouring billions and billions in R&D on better processors, better cameras, better radios, and everybody in these small satellite revolutions harnessing those technologies. So they basically get technology for free, and they're putting them in these spacecraft. And those consumer electronics will work in space for 3 years, but 3 years only. So you have to basically deploy and replenish your constellation every 3 years. But however, what I can get out of that is really small, really high performance spacecraft. And you're saying, okay, that's great. You can launch a constellation of really high performance spacecraft, but what are you going to do with it? Because at the end of the day, VCs are very good at making money, so they're only going to invest this money if they know how they're going to make their money back, preferably 10, 20 times what they invested. And what we're seeing, both from our spaceflight business, but also with Black Sky, what I'm about to talk about, is what everyone wants to use these small satellites for is to look at the globe in real time. And let me just take you on kind of a thought experiment for what that means. I mean, right now, you guys all can pull out your phone, you can get on the internet, what your friends are doing, what they're doing, where they are, what they had for lunch, what they thought about what they had for lunch. You know everything about your, personal ecosystem, but you know nothing about the planet. How many trees were cut down yesterday? How many cars were produced in the United States last week? We live on a planet where if you add up the GDPs of all the countries on the planet, it totals $78 trillion, okay? Countries and companies and nonprofits, they spend 1% or 0.1% of their budget doing market intelligence, military intelligence, homeland security, economic monitoring. And so that says, if you look at it, the satellite imaging market, and I'll just focus on that for the next half of this talk, it's $2 billion today. But if you take the high, big picture view, it should really be $200 billion or $2 trillion, because once you understand what's going on the planet, there's a lot of value with that. And people spend a lot of money today putting people in airplanes and trucks and flying drones just to understand a small piece of what's going on the planet. So again, you can use satellites to scale and start looking at this planet in real time. And ultimately, we're going to look at it in all spectrum. It's going to be in the visible spectrum, and the infrared spectrum, and the RF spectrum. And that's what you're seeing. The money that's going into these companies is really going to deploy constellations that are going to look at this planet in a whole new way. And so with that, I want to talk a little bit about what we're doing. As you saw previously, we build satellites, we launch satellites, we operate satellites. So we could sell that to you, but we could also let you lease it. Just like I could sell you a car, or you could lease a car, or you could timeshare a car. There's new businesses that are going to be deployed to enable this data collection on the planet. So about 3 years ago, we were watching the trends, we were watching Planet Labs, we were watching Skybox. And ultimately, what these small satellites do is provide very high revisit rate. And having done all the work for the Army, we thought we could do it differently and even do it better than what had been proposed previously. So I went out and started another company. I have a problem. I started too many companies. And started Black Sky Global with the idea that we're going to do two things. What satellites do, they're very good because they provide global coverage. They're very expensive to build. They're expensive to get on space, but they're very cheap to operate. But because historically they've been so expensive, you can't put up a lot of them. So this whole UAV market proliferated. And it grew very fast. In the course of a decade, it went from nothing to $10 billion annually. And they're good at local coverage and high frequency. They're cheap to build, but they're very expensive to operate. So take the best of both approaches. Take UAVs, put them in space, and what do you get? What you get is you get global coverage, you get cheap to operate, cheap to build, and that's really what people are doing with these constellations, and it's not just us. And if you look at the imaging market today, and this is an industry report, this is, people use it for defense and intelligence and agriculture and energy. You can look at harvesting resources better. You can look at providing services. You can monitor oil production. You can monitor all sorts of commodities. And so that's what I'm talking about. Is we're taking, right now, the state of the art is if you want to picture the planet, and if you're not president of the United States or president of a country, these imaging capabilities have been the exclusive domain of the intel communities of a few select Western countries. But ultimately, if you start thinking, and if you wanted a picture, there's companies you could call Airbus, you could call Digital Globe, and you're literally calling them, you're not going online, and you talk to them, you order a picture, it's going to cost you a couple $1,000, it's going to take you about a month to get that picture. But where we're going in the future, it's not just us, it's everybody. It's about getting on your cell phone, order the picture from an get that picture back in an hour, and it probably costs you $100. And when you do that, suddenly you transform a whole bunch of businesses. You transform how we think about the planet. You're really democratizing access to the data. And it's a very interesting thought experiment to take that into every industry, niche, and sector, and how that changes our society and what we do it. And what I really think is we're entering what I call geospatial 3.0. For those of us relatively older in the room, we grew up with maps. For the younger people, you grew up with Google Earth. That was generation 2.0, where you could go online, you could look at the planet, you could scroll. But now we know what the planet looks like. Now it's about how has the planet changed. And that's really what we're doing by putting up a constellation that was only up there for a couple years. What we can do, though, is put up a lot of satellites. We can put them up at mid-latitude. And what it allows us to do is see the planet 40 to 70 times a day for certain locations instead of once or twice a day. And you can get that data in hours instead of days or weeks. So that is the big picture on what we're doing in Black Sky. We'll have more announcements on how we go forward. But as far as our build-out plans, well, actually, let me talk about one last thing. And this is just to give you a comparison to what's out there. A lot of people are pushing for high-resolution imagery, and this is a port picture, and I show it in 3 different settings. You know, at the Planet Labs imagery, they provide really good imagery. It's good for agriculture, but if you want to look at the basic economy, you really need 1 meter imagery. That's why Skybox focused there. That's why we're focused there. You need to see cars, trucks, trains, and infrastructure. That's why the Army focused there. And the same globe, driven mostly by U.S. government requirements, has been done at 1/2 meter or 1/4 meter accuracy. So there's a lot of market opportunities across the whole spectrum. And what we're doing is we have 6 satellites that are funded. We're going to get them up here in 2016. And then after that, we're going to go continue to build out our constellation. We'll put up approximately 20 satellites a year out there. And what's key here you see is after 3 years, we go into sustainment mode. And that's because of those commercial components, because we want to be relevant with Moore's Law. We want to constantly be launching and deploying and replenishing our spacecraft. That's not just us, that's anyone using these small satellites, because that's the state of the technology. So with that, I'll pause, but I just want to leave you with that lasting question. You know, where we're going, where are we doing at NewSpace, where's that future market opportunity? It kind of leads into the next panel about constellations. It's really these constellations are going to allow us to look at the planet in a whole new way. And there's tons of opportunity. We're really talking change, disrupting the current military-industrial complex, smaller satellites, to look at the planet and the data, it's the commercialization of the data. You're already seeing that today with Planet Labs, you're seeing that today with Skybox and Google. And so it's an exciting world we live in. So I conclude with Rick Tumbleson's Welcome to the Revolution.
Systems in 1999 as Andrew Space to be a catalyst in the development of affordable, high-performance satellite components in spacecraft. Andrews then founded Spaceflight Services, the space logistics company, in 2010 to provide cost-effective commercial rideshare launch services that open up access to space for more solutions and organizations. In 2014, Spaceflight expanded its services to include Spaceflight Networks, a business dedicated to cost-effective spacecraft communications and operations for small satellite providers. Under Andrew's direction, all of these companies were combined and rebranded under the Spaceflight name in 2015 to form Spaceflight Industries. Now, Andrews and Spaceflight are out in the landscape of Earth imaging with Black Sky Global.
Honors, we were a NASA COTS finalist, which is the Cargo Logistics and International Space Station, the commercial contract. We were a finalist twice. We're the only company to do that, not win at a time, which just meant we spent a hell of a lot of money and didn't get anywhere. We had other great foray space into space transportation, but ultimately, I feel your pain sitting in the audience. If you're an aerospace entrepreneur, I've lived through it. Going up against the military-industrial complex is very difficult, and I've learned those lessons. And so in 2008, after being at it for 8 or 9 years, I pivoted the company and focused on this emerging technology called CubeSats. So this is 2007, 2008. CubeSats are ubiquitous today, but a decade ago, it was very much university lab stuff. No one had really come up with a commercialization case. The government wasn't thinking about CubeSats. In fact, the government looked down and looked at them as just toys that should be discarded. They call them space debris. So, Iridium Global Star. And that party went on for about 3.5 years. Unfortunately, the party came to an end in 1998 when all those companies went bankrupt. And Isler ultimately struggled and had to reset. And I ended up leaving. So what I want to do today, during that time, I came to my first NewSpace conference. And if you remember, it was probably a fraction of this size, probably like 25 to 50 people. And Rick Tumblson will get up and he'd yell into the microphone, "Welcome to the revolution." And so it was exciting. It was an exciting revolution at the time to be part of that industry. But unfortunately, it kind of went into a dark period because once the street and all the financial markets lost billions of dollars on those companies. There has not been major investments really for 2 decades until now. And I feel like we're starting to live through a transition, and hopefully this one has more legs and lasts longer. And so what I want to do this afternoon, I recognize that Starbucks closed at 2.
At a given point on the planet with a time resolution of only hours. Please join me in welcoming Jason Andrews, CEO of Black Sky Global.
Okay, can everyone hear me? Well, first of all, I want to thank NewSpace for allowing me to be here. It's actually an anniversary this week. Actually, 20 years ago this week, I joined the new space industry. Actually, I joined the space industry. I took my first job out of school at a company called Kistler Aerospace Corporation, which was one of the new space in the mid-90s that was there to launch all the satellites for Iridium, Teledesic, and Globalstar. And so we lived through the first, or me personally lived through the first new space revolution in that we developed a company. We went out and raised $400 million. It was there. A lot of capital was flowing into the market. Billions of dollars flowing into companies like Teledesic sometime after 3, and so we're trying to stay awake, so hopefully I can do that. But what I want to talk about, I'll tell you a little bit about my companies, talk about my journey through NewSpace, and talk about where we are today, because it's been a bit of a wild ride through as Hannah described in the introduction, and more importantly, talk about where we're going and the excitement about what we're doing, not only in spaceflight, but in the black sky. And it's not just us, there's a lot of people who are a part of this excitement. And I will get to that in a second. But going back to the beginning, again, I kept my teeth at Kistler Aerospace Corporation. I left and started my space at the time. And what we were, having just been part of a company that went out and raised $400 million in private equity, and unfortunately spent a lot more than that, I wanted to focus on revenues. And so we went out to the U.S. government, working for NASA, worked for the Department of Defense, worked on commercial programs. We had many dubious